squared. All right, we're going to assume that y equals e to the m times x is a solution. And we're going to be interested in finding m to be our solution. So there's also other theory that's revolving around this that I don't have time to talk about, but we're looking for two solutions. We're looking for two solutions. So that part of the theory we'll just accept for now, and then you'll learn it in your class. Anyways, if I plug this into this differential equation, I need y prime, which is going to be m is a constant, so it'll be e to the m times x times the derivative of m times x, which is m. And then y double prime is going to be m squared e to the mx. Okay? And so I'm going to take this and put that into my differential equation. So I have y double prime, which is m squared e to the mx, minus 3 times y prime, plus 2 times y, and that's equal to 0. And so what I would notice here is that e to the mx is common to all of them. It's common to all the terms, and then all I would have left is m squared minus 3m plus 2 equals 0. And I am looking for m, so it looks like this will never be equal to 0. So I can just ignore that. And then this, I can factor, I think if I did this right, m minus 2, m minus 1. And then the solution here will be m is equal to 2 and m is equal to 1. So it looks like my solutions for the differential equation is going to be, I have two of them, so I'll label it y1 e to the 1 times x, and then y2 e to the 2x. So my general solution is going to be y equals a constant times the first solution plus a different constant times the second solution. Okay, again, more theory behind this to say that you need two solutions, and your general solution would be the linear combination of those two solutions. So that's how we got this for the answer. All right. So just remember factoring when you get to this point in your course where you have to do second order linear differential equations with constant coefficients. It's a nice and easy process, I think. And the only thing you really need to remember is how to factor. Okay? So I'm going to go ahead and do one more problem. Okay. Hold on, Alvin. Let me pause for a minute. This is how you would solve this particular problem. And again, there's some theory that we're kind of glossing over. But I would like to use this problem and the other problem that we did, the first order linear that we did yesterday. I'd like to use those two problems as an example of Laplace transforms after you've kind of gotten into it a little bit, okay? So my idea was to let you dive into more Laplace transform type things, and then we'll try to come back and do these same problems to see if we come up with the same answer. Is that cool? All right. Sorry for keeping you. I'll let you go for about half hour, 45 minutes or so, and I'll check in.